Good morning. Welcome to another episode of Xa Talk Show. Today is Friday 10th, 2019, and we are going to do a lecture on closure, the concept of closure. And I'm going to show you what it is, and I'm going to code it in emacs lisp, in JavaScript, in Python. Okay. So, let's start. Let's go to talk show, and closure. And gonna put that here. So closure, okay. JavaScript, emacs lisp, and Python. I'm gonna show you what it is. Closure and other things. Okay, so oh, 3 people watching, great. So if you are here, say hi. And I'm going to go straight to closure. Let's see if I have my Windows set up correctly. See, I'm talking, and in my hands, that's good. And so let's start. So let's go to Xali closure. Okay, I have several articles about closure, and this is the main one. What is closure in programming languages? And I'm gonna show you JavaScript, closure in JavaScript, and in Python and emacs lisp, Python 3. Okay. Good morning, break the loop. So break the loop says I finally got the mouse I'm happy with. Logitech G903 works for my left-handed, has medium buttons, infinity scroll, and true programmable binding. Oh, that's great. So G903. Now, which one is G903? Let's go to my keyboard. Let's get back to closure, but let's look at this just quickly. G903. Oh, okay, this one. This one is expensive, fancy mouse, wireless, and super light. Well, not super light, but fairly light compared to all the other wireless ones. And it's dedicated, it's designed for wireless gaming mouse. That's great. I didn't like this one in particular. I mean, not this one is not my ideal because the number of buttons are not that much. Uh, because you have two on the left side and two on the right side, and I don't like ambidextrous mouse. When they have ambidextrous mouse is a fancy jargon used in the mouse gaming community. They call it ambidextrous. Ambidextrous means uh, it means a characterization of people's ability to use both right hand and left hand. So some people are right-handed, some people are left-handed, and some people is said to be ambidextrous, meaning that they can use either hand equally well. Actually, I'm not sure that is actually true, or what percentage of people are actually like that. I haven't thought about this. Thinking about it now, but anyway, that the ability to use both right hand and left hand, that concept has always fascinated me, and I always try to do that. But naturally, I'm right-handed, but I always try everything to I learn something with my sometimes with my left hand first. Sometimes I use my left hand to brush my teeth, and I've learned to write with my left hand. Not well, I haven't been practicing it, but I try to do everything with left hand as well. Because the idea of ambidextrous, meaning it's a capability, in a sense like a Superman. If you can do everything so well with both hands, that is great. So I've been trying to do that. But anyway, back to the mouse. Ambidextrous So that word actually describes the ability to, a kind of natural ability to use either hand. But in the mouse community, is simply used for as a jargon. It basically just means the mouse is symmetric. Symmetric. Now, I don't like symmetric mouses because when you have a symmetric mouse, that actually practically it just means, you know whatever buttons on the other side, you'll never use it, or because it won't be optimal. It won't be, you'll it will be hard to use. So, if on the other side, whatever number of buttons they have, maybe you can only use one of them. So I don't like ambidextrous mouses. And it got, these three buttons on top. This button, this button, one of them is controlling the spin wheel. Let me show you. Yeah, since I'm okay, I'm going to get back to the closure. Okay, but this mouse is just a fascinating topic. Let me show you. Hold on a second. Let's see. Let me point to that's Windex. So let me show you. So mouse, right? So you got this button. Okay, that's the you see now it's spin mode. It spins. Now if I press that, now it's clicky. It doesn't spin. So it's Logitech's mouse has this feature. They call it hyper wheel. I think the mechanism it's patented. It's patent. So I think because you don't see it anywhere because they have, I guess they have a patent invention. But anyway, I spin wheel is absolutely necessary, because let's see, let's show. For example, you can see spin wheel in action. Hold on a second. You see, I can, it's spin wheel in action. It's fantastic. Now, especially in Linux, especially if you are on Linux operating system, because Linux operating system is sucks so bad in every way. Okay, because it doesn't have accelerated wheel. In some browsers you might have it, but it doesn't have a system-wide acceleration of scrolling. And when you look into it, on a website on Arc Linux side, or the idiot Linux people, they say, oh, it cannot be done, or it's difficult to do, or we don't want it because the third button is because for this or that. It's, stupid Linux people. That is why they never get anywhere. They are the Linux system, although it's open source, it really should have already been wiped out Microsoft, Windows or whatever. It's free, free people, but the system is just so bad. That's why, in general, Linux things and these hacker types, geeks, us in a sense, us never go anywhere. uh, I mean, this without scrolling wheel acceleration, it's patently stupid. Okay, because on Linux, if you don't have a scroll acceleration like right now, I see. Look at the actually. I'm on a Mac, because on a Mac you have acceleration, built in, and on Windows there's a scroll wheel acceleration. On Windows, the last time I looked at, which is about 4 years ago or five, you do not have scroll wheel acceleration by default. Okay, but if you buy any Logitech mouse or Microsoft mouse, then you have scroll wheel acceleration. Without, it's extremely stupid. Like actually, it's like then you have to use page down, and the problem with page down is that sometimes you like page up, like this is halfway, like you have an image that's halfway, you page down, you only see the other half. So it's this, so it's no good. Okay, you want, then you have to use arrow keys, like adjust it a little bit. It's really stupid. But on a Mac or Windows, when you if you have scroll wheel acceleration, that means that means, for example, I actually turn it off because I have spin wheel. But let me show you when I have a scroll wheel, scrolling wheel acceleration, turn it on. So I'm turning it on right now. So I can go to like any page by any position in this long page by just a flick. Like I can go slowly, like right now I'm going very slowly, or I can flick, all the way to the bottom. You see, you see how that is, like these pages 1 2 3 4 5 6 7 8 9 10 11 12, it's like 20 pages, 20 screen pages. Now with wheel acceleration, I can go all the way down. Okay, 1 2 3, just 3 wipes. Now if I do not have acceleration, it's like, and this, by the way, I think when you turn this all the way to the left, it still have a acceleration. So it's actually, this is already actually working well. But on Linux, it's like it doesn't matter how fast you try to scroll. It's like each time it's like it's extremely painful. Okay, so this is another example of the extreme idiocy of the Linux people, the hacker types. I know a lot of you. They'll say every time we talk about Linux, they'll say, "Oh, I have no problem with Linux. Linux works great for me." Yeah, that's all. Um, you are not actually, you are you are delusional. You are not actually, you are biased. You don't see so many aspects of things. I mean, let's be concrete. This is one concrete example. Try to tell me that, accelerated score doesn't matter. Try to say that. You cannot, and also a lot of people, Linux people, for example, in this case, they might say, "Oh, I don't need it because, I page down, page up works fine for me." Actually, no, because a lot of us, it's simply your habit. Like right now, like if today I don't have spin wheel, I don't have Logitech mouse, and suppose I don't have you know on Linux, you just get used to it. That's how flexible adaptation humans are. Like we went to the moon 50 years ago without, at the time we don't have computers. We don't our computers, it's what's the memory size, 1 megabyte memory size. We are still using slider rules, but we went to the moon. That's extremely complicated engineering. But we human, you know how difficult something is, it's all relative. We just walk through it, so we can almost overcome, in a sense, overcome anything. People in prison, they are great mathematicians who are in prison, like all their life or something, or for decades, and they created, some of the greatest theories, or not even mathematicians. You can see, some of the people in fictions or in movies, people in prison, they just do things, they get creative. And so, in a sense, back to today, we are all kind of very spoiled. We we live on social networks, and anyway, back to the acceleration. So I turned the acceleration off because because I have spin wheel. So spin wheel, when you have spin wheel, it's best not to have acceleration, because the speed you scroll the page will be solely depend on how fast you spin the wheel. So you can control it, more precisely. For example, this is my emacs page. I can spin it. Let me show you. Okay. Let me show you. Okay. You see, right now, even in emacs, I turned off acceleration. You can turn it off by, if you just search Xali emacs mouse. Okay. Yeah, Xali emacs mouse setup. You can find how to set up the acceleration in emacs. Okay, not this one. How to change key binding? Computer. Emacs mouse setup. Well, it's here. You just go to the keyboard setup and you'll find a link to the, yeah, there. How to set mouse buttons. How to make mouse wheel not accelerate. Yeah, this page. So anyway, that is about mouse acceleration. Now let's go back to, yeah. So this mouse, I get, I always have a itch to buy another mouse, even though I have, you know, quite a few. They are not all ideal, but you know, so this one is great because it's wireless, but it's not ideal to me though because it's symmetric. But it's, it's wireless. One of the great thing about it is it is wireless. Um, uh, there's a lot of things about, I in general I don't like wireless things because when you have wireless, it's prone to, hacking. Hackers, they can listen to your mouse devices. Whenever you have higher wireless, it's always prone to that risk. And doesn't matter it's Bluetooth or customized radio wave, it are always prone to being hacked. And you don't know. I mean, you can't know those things. So let's get back to the mouse. So let's see. Let's get back to the comments. So I got 8 people watching. So feel free to comment. Okay, say anything opinions you have. So break the loop. Break the loop. I use mouse wheel lean left and lean right for 2 more buttons. Okay, like nudge left, nudge right. Okay, and I rebind those 2 DPI buttons below mouse wheel to other functions. Total 11 buttons. 9 easy press, too difficult. Okay. Yeah, the other thing not ideal to me about this Logitech mouse is, you see the middle buttons is kind of like two tiny small ones in the middle, so that's not, I mean, it's not ideal. uh, that is all. But like when you look at people who are obsessed about mouse or keyboard, you always find people like they always complain, yeah, I looked at all the hundreds of keyboards or mouse, but they are not just ideal because this one is missing that. Each person has always have differences, little preferences. So anyway, I'm glad you find the ideal mouse for you. Yep. So of you guys out there, you want to buy a mouse, go to my website. Okay, sorry, just search for my mouse page. I have tons of reviews, and buy it from my web page. So let's see, where's the mouse? Mouse trackball. Here's another interesting topic. You see this Apple scums, Apple and Google, these company scums. You see this mouse, this is, you know what that is? That is a Unicode, okay? That is a Unicode for 3-button mouse. Now, when you are in Mac OS, when you are in Apple's platform, iPhone or Mac, they show the 3-button mouse like that. So so this is a situation where the emoji, the Unicode character emoji has become very politicized and commercialized. The idea of Unicode is that for communication, it helps all human animals. You have one encoding, and you can have, you can express Chinese, English, Italian, French, all in one language, or Germany or Japanese, in one encoding. So you have multiple language, and then you have emojis, supposedly to help us communicate or for fun. But today, since about 5 years ago, they these emojis become politicalized, and they are also used as a commercializing marketing tool. So because for example, let's go to Unicode. Okay, so here's a Unicode page, and you go to the tech. Okay, these are a bunch of technological devices that has a emoji representation. Now you see this character is three button mouse, but if you are on a Mac, it shows like that. I mean, does that look like three button mouse to you? No, but of course, Apple, Apple wants you to think, Apple or Mac fans, they think this is superior. This is their version of three button mouse, with touch and all that. They like you, but it does not communicate. First of all, if you look at the mouse population, the mouse market, what people think when it comes to three button mouse, the vast majority are not Apple's mouse. Apple mouse is just the elite, the wealthy elite fox. So but it does not serve the purpose of communication anymore. These companies, each company, they just use it to promote their own product, their own platform. So on Mac OS, three button mouse looks like that. And so you have this one is called one button mouse, this one is two button mouse emoji. So it's like political. So it doesn't, it does not serve the purpose of communication. And same way for other emojis, and also Google is one of the most evil in their emoji as well. Like these emojis, when you are on Android or Google Chrome book, Google platform, Chrome OS, they you know they all these emojis look like android heads, like it used to have antenna, but now they removed that. It looks like extremely creepy. It's like this blob, this semicircular blob. Actually, I have a article on this politics of emoji, Unicode for programmers, emoji equivalence. I don't have it linked there because it's a emoji politics. Let me show you this page. Okay, then there is the social justice aspect. Okay, we're not going to talk about that today. I talked about that before. But anyway, look at these are Google's emoji for smiley. So why they look like this creepy, is it's a matter of judgment, but this was not what emoji smileys common conception of smileys with this semi-circular blob, and it really looks creepy to me. It looks like that because it was it was represented by Android, the Android logo mascot for Google's Android phone, with a kind of bot, robot with antenna. Google's logos and mascot has always been very cold and very ugly and very, for some reason, Google, and they become an evil empire. Somehow reflects actually their choice of emoji. Because look, emoji and logos. Because look at Google Chrome's logo. It looks like a UFO. Like if you look at all Google's logos, all their products logos, oh, one exception, Golan. Okay, there's one exception, Golan. Golan has this cute mascot of a gopher. So this is one exception, Golan. But all Google's product, you look at their logos, they are always kind of cold, devoid of any humanity, devoid of any uh, of humanity or animals or anything like that. It's always like just code and machinery, like Google Chrome's logo. So for some reason, Google's logo has this kind of knack, has this kind of uh, situation. across Google. And this is even before Google became evil. So for some reason, I'm not sure why. I'm not sure. Maybe there is a company wide, you know, thesis about what their logo should be. To maybe they have a internal publication to all the logo designers. But I'm guessing partly it's because Google has always been very engineer driven company, at least in the beginning, in the first 10 years. Is everything is based on statistics, on measurements, so they are like, in a sense, inhuman. That's what that word means, inhuman, because they human, or being human, is not necessarily a good thing in many respects, because as human animals, we have prejudices, we have biases. It's built in our brain. It's actually just built in. And so we are, our emotions, and the good parts, the bad parts, empathy, our connection to other people, love and hate, it's all part of us. That's what we call it, human. It's humanity. Humanity, the human issue. That's a big unsolved and almost undefinable issue with us. That's humanity. uh, that's the thing about humanity. So, but Google has been always machine and engineering statistics driven. And by the way, also, we actually, it's impossible today. We don't have a solution. We are unable to define what humanity means actually in any precise or mathematical way. So that's also part of the problem. So anyway, that's digression. Okay, let's get back to the comments. Then we're gonna start to talk about closure. I'm going to talk about that project, that subject for sure, because that was what was promised. Okay, so Yujian Zen says, you Zen says, I cannot buy this in China. I cannot buy this in China. Maybe you can add promotion link to some Chinese online store. I don't have affiliation with, I don't have any link like that. So I don't know actually, those Chinese online shops, they have affiliation. I haven't looked into. So if you are in China, just, I guess, buy it from China. But actually, if you are in China, then I do not recommend you buy these American Logitech, or or European things, because in China, these Logitech or others, they are extremely expensive. They are more expensive than if you buy it in US. And on the other hand, while in China you have tons of almost equivalent, and they are like 5 times cheaper. So actually, in China, I would recommend you just buy spend some good money, buy a Chinese ones in China, because that way the ratio of quality features over the price is much better than if you buy a Logitech. So Break the Loop says, I require ambidextrous mouse because I'm left-handed. Yeah, that is true. There are left-handed mouses. There are a few of them. They are rare, but I have a page that show a few left-handed. But then it's rare. Then the features are not comparable, because then some of them don't have wireless. Some of them are not gaming. Yeah. So yeah, you just go with the ambidextrous mouse, or rather the symmetric shaped mouse. Yes, infinity scroll is good. So do you usually have it set on smooth? Yeah, I always have it set on spin. Uh, Spin mod. Yeah, smooth. But occasionally I find clicky better. I mean, occasionally, just occasionally, clicky is better for sometimes I want clicky, but usually I'm just too lazy to switch to clicky. But also when you switch to clicky, then I want the acceleration, but then I have to go to preferences to set it up, or so that's too much trouble. So usually I just always have it on spin mode. Oh yeah, so but I used to, I usually have another mouse on my left hand. I always use two mouses. So on that mouse, or sometimes it's a trackball. That mouse is clicky. So whenever I want to clicky, I just use that mouse. So Norman says, hi Norman, infrared wireless is close to impossible to hack unless you are in the same room. Well, yeah, of course, you have to be in the same room, you have to be in the range, right? I have always found the Google design and UI aesthetic ugly. Okay, hi, can you explain why Emacs is bad with big files? Uh, it's just because Grindex asked that question. That's just because I don't have technical details, but I'm pretty sure I know the answer. The answer is just because that's the way Emacs was coded. The design of the, how it is coded in the beginning, 30 years ago. Yeah, you know. So I don't know the technical details. And I don't actually know much about low-level programming. But I suppose it has to do how do you implement, like you have you know in the case of Emacs, when you read okay, here's the reason. When you read a file, when you open a file into a buffer in Emacs, it has to load the whole file, from the first character to the last character into memory. Okay, that was what Emacs has to do. And that is not the case in modern editors. I don't think so. So again, I'm not sure about details, but I'm pretty sure that is the reason. One thing I know for sure is that when you open a file in Emacs, it becomes a buffer, right? It has to load the whole thing into the buffer. And also the other thing is that Emacs judge cursor position by it's called the point. For example, I can say point point to register. Anyway, so for example, I can call this command describe char, and it'll tell me what position I am on. So the position is just for example, the beginning of buffer. If my cursor is at the beginning, that cursor position called point is 1. Okay, it begins with 1. For example, I call describe char, and you can see it says 1 here. So the cursor position is where your cursor is, and that when you code Emacs or every command in Emacs, and moving cursor or whatever, it's actually coding Emacs lisp command, and Emacs lisp command in turn is working with cursor positions. So it has to know. So in other words, the maximum file Emacs can open depends on the maximum integer Emacs can represent. So a few years ago, almost 10 years ago now, so Emacs has a limitation. It cannot open any file larger than few hundred megabytes, something like that. This was 10 years ago because the maximum integer, it was 2 raised to 28 or something. I think 2 raised to 28 today, something like that. Anyway, it's an integer. It has to, the maximum number of characters must be less than the maximum of number of representable integers. Anyway, so that was the case. Today I don't know what is actually we can find out by just calling max intert. Let's see, switch to Emacs list mod max integer. Okay, so wait, control max. Anyway, there's a variable that shows you what is the maximum integer, and that is basically the maximum file size you can open, basically something like that. Okay, let's go talk about closure. uh, so let's talk about closure. So first of all, so I'm gonna tell you what is a closure. Okay, now remember this, okay, carefully. Closure is a feature of programming language. Closure has nothing whatsoever with to do with theoretical computer science. It has absolutely nothing to do with mathematics. Now, some of you advanced people may not agree, okay? When I say closure has nothing to do with math, you may say, oh, I disagree because, well, that's up to debate, okay? So, anyway, I'm just going to give you my point of view. Now, first of all, you want to understand what closure is, right? Closure is kind of advanced, we would call it advanced concept in programming or programming languages. So if you are, if you are beginner programmers, if you have just 2 years or something, you may not know what it is. But I'm teaching you what it is, okay? First of all, understand that closure is a feature, a specific feature of programming languages. So that means in some languages, for example, in some languages, a function can take a function as argument, and return a function as a result. Some programming languages can do that. Uh, Haskell can do that. Lisp cannot do that in general, but you kind of have other workaround. JavaScript can do that. A function take a function as input and as argument, and return a function as result. So JavaScript can do that. Haskell can do that. Mathematica can do that. Some programming languages can do that. Some others cannot. While programming languages, they have different features. So that's differences in programming languages. So remember, closure is just a feature of a specific feature of programming language. Some languages support it, some not. And also, when you have a feature in particular language, some programmers love it, like it. Some other programmers don't care for it. Some programmers think, oh, I never use that feature. In fact, I think that feature is harmful. Some people may say that. Depending on what feature it is, depending on who you ask, depending on what programming language it is. So first of all, remember, closure is just a feature of programming language, of a specific feature. Some people like it, some people don't. In C, you don't have that. In general, in the imperative programming languages, you don't have that. In C, C++, Java, I might be wrong today because they might have added that in the past 5 years. Because in the past 5 years, you know, a lot of functional programming concepts are introduced to the imperative programming languages such as Java. They began to have lambda. And okay, so again, so it's a feature. Okay, now what? Now, okay, so some people like it, some people may not like it, and is it necessary? No, it's not necessary. Again, it's just a feature. uh, and it's not even necessarily okay. In my opinion, I don't like it. Okay, in my opinion, I do not like closure. Okay, and I never use it, and I will never use it. Basically, period. Okay, I have never. I've been programming for 20 years. I have never used closure, and I will never. Basically, I will never use closure unless if one day I work in a company. When you work with in a company's project, you cannot just do what you want. You have to follow, already, maybe there's already closure. You follow, what's already existing style, and you follow the company's guidelines. That's when you work in a team. But personally, I will never use Clojure. I will never, recommend it. I don't like it. Okay. And and to me, of course, it's obviously not necessary, and in fact I think it's harmful. When I look at other, this is a matter of opinion. Okay, some people may agree, some people do not agree. I don't like Clojure. Okay, that's it. I don't like it. I'm gonna tell you why I don't like it, after I explain what it is and so on. But first of all, I want to try to teach you, any of you new programmers, okay, what Clojure is. Let us see. Okay. Now again, guys, don't post anything that can get me banned. Okay. Um, so back to Clojure. So Clojure is a specific feature of programming language, and of some programming languages, and JavaScript has it. Uh, Python 3 has it. Python 2 does not have it. Okay, Python 2 you cannot do it, but Python 3, it's a new version of Python. You have it. You can do it, and emacs Lisp has it. Okay, so but it was introduced about 3 or 4 years ago. So before that, you don't have that. You don't have Clojure in emacs Lisp, but they added that. Okay, so again, it's a feature of programming languages. Some languages has it, some doesn't. So what is it? What does it do? Okay. Now the other thing important to now, I'm going to give you itemized things. I want you to remember. I kind of, I tend to be repetitive, repeat, myself, but I kind of think that's also important, because when you go out read the online websites, if you type Clojure, you'll find hundreds, of articles. What is Clojure? They tend to be, in my opinion, they usually tend to be confusing, and they don't capture the gist of things. And also today, half of them is just clickbait. Companies, they want to make money, so they want to write up articles so all the people go to their website. So they get money from their ads, even though they don't care nothing about programming languages. They just copy paste, from Wikipedia or other things. They hire cheap laborers, in China or whatever. They pay you $5, an hour to so you, as a beginner programmer, you copy and paste, information for them, and you create an article, and then they put on their website, what is Clojure, the 10 things you need to know about Clojure, things like that. There are tons of websites like that. That's one thing. But then another thing is that a lot of programmers, they don't really understand, they don't understand programming languages, including a lot of these elite hacker types. They're like, for example, perl people 20 years ago, they have, yeah, I'm gonna show you. They have an article in their perl documentation, official perl documentation. They tell you what is Clojure. Let me show you. This is so funny. Clojure. Okay, this is what perl people say. What is a Clojure? About 20 years ago, 15 years ago, in their official documentation. Um, let's see if I can find my article. Perl Unicode tutorial, Perl script to check HTML files. Um, Perl doc, maybe it's here. Yeah, that is the one. Um, this is Perl doc, Perl F. Oh, Perl FAQ 7. Okay, I might be. Um, let's. So here it is, Perl doc, Perl FAQ 7. What is Clojure? Clojure are documented in Perl. Oh, here. Okay, Clojure are documented in Perl ref. Okay, here, the page you are looking at is Perl FAQ. Okay, frequently asked questions. That's a common term throughout 1990s, but today you may not be familiar with FAQ. That means frequently asked questions. But here is the official doc on Clojure. Let's see. uh, yeah, okay. Let me just show you some of the you read this and you can see, you can get the context, the idiocy of these people. These are considered elite hacker programmers. Remember, we are looking at perl ref, perl doc, perl ref. That's the one of the official documentation of perl, and the perl ref is a chapter on Perl references, the concept of reference in Perl. Okay, this is official documentation of Perl. And the other page here, Perl FAQ7, is also official documentation of Perl. They talk about they trying to tell you what is a closure. Let's read a few paragraphs. So here's it is. What is a closure? Closure are documented in Perl ref. Okay, but let's keep reading on. Closure is a computer science term which closure is a computer science term with a precise but hard to explain meaning. Usually, closures are implemented in Perl as anonymous subroutines with lasting references to lexical variables outside their own scopes. These lexicals magically refer to the variable that were around when the subroutine was defined. Deep binding. This is complete idiotic, nonsensical, and they don't know. It's like convoluted. They don't even know what they are talking about. First of all, closure is a computer science term. Wrong. Closure has nothing to do with computer science. Okay, closure has no foothold in theoretical computer science. Closure has no foothold in computer science. Period. Rather, closure is a computer engineering kind of thing aspect. Okay, closure is it has to do with practical programming. Closure is a computer programming language feature that exists in some languages but not in others. It's just a computer engineering issue. It has nothing to do with computer science. And look at this, how they phrase it. The way they write it means, it means they have no understanding what it is. This is typical of programmers. This is typical of programmers understanding when they try to explain something in programming, even for something they think they know well. Okay, this is typical. This paragraph about Perl people trying to explain what closure this is. And what I'm saying applies to this all these Unix fuckheads. This Unix, you think they are smart. The C programmers, they actually don't understand what they are talking about because they don't have a clear mathematical grasp of what's actually going on. Instead, what they have instead is the programmers, the elite hackers, they call grok. This fucking stupid jargons. Like they grok things, grok. It's like some kind of empathy. They feel like the Unix philosophy fuckheads, the Eric ESR, Eric Raymond, the guy who created Bazaar and Cathedral, who wrote that crap. So this Unix philosophy type of people, they like to say they grok. It's like they feel how things are. They that is what this Perl people is doing. This is a very concrete exhibition of these Unix fuckheads, these idiotic elite hacker type of programmers. I'm giving you a concrete example. I'm showing you my opinion, and here's his example. I say this is an exhibition of their. This is an exhibition of a illustration of how they, how the situation of where they think they understand something and how they try to explain it. Okay. So they say closure is a computer science term, which is incorrect. Then they say look at the way how they say things. Closure is a computer science term with a precise but hard to explain meaning. that is stupid. First of all, the first sentence describing closure, they are actually not trying to define what closure is, but however, they are trying to give you a flavor of what they think closure is. It's a they say it's a computer science term, but and they say it's precise but hard to explain. that's that's almost like mathematically that's contradictory. That means they don't understand. They either don't understand what it is, or it means they are unable to explain what it is. Like they do not understand something fully 100%, but they kind of understand it, and that's what they say. With a precise but hard to explain meaning. What do you mean something is precise but hard to explain? Okay, let's take it for face value. Yeah, it is true that something could be precise but sometimes hard to explain. Okay, yeah, let's accept that. Okay, then they say usually closure are implemented in perl as anonymous subroutines and so on. Then you can see here immediately they switch. They kind of switch the approach. So instead of telling you what closure is, in general, they immediately tell you what closure is implemented in perl. So they are not even telling you what closure is in perl, but they tell you how closure is implemented in perl as a way to kind of explain what closure is. This is their method of trying to explain something. So they don't know what closure is mathematically. They don't know what closure is in computer science. They don't know what closure is in general, or they fail to explain it. They are unable to, or they choose not to. Okay, then they start to say. They start directly to go into how closure is implemented in perl, and usually with a qualification. Usually closure are implemented in perl as anonymous functions, subroutines, and so on. So they don't even try to directly explain what closure is in perl, the language. Because again, as I said, closure is a specific feature, and in different languages, and also the way they closure exhibit behave in different languages also kind of differ. So again, like I said before, closure is not a mathematical concept. It has nothing to do with math or theoretical computer science. This kind of proof, it proves solidify my point that closure has nothing to do with math or theoretical computer science. Rather, it's computer engineering thing. Different languages have different language designs. Some has closure, some does not. And of those languages that has closure, they actually do, the way they kind of the semantics is a little bit different. Kind of So anyway, back to the Perl. So they try to convey to the readers. This is frequently asked question. They try to answer the question, what is a closure, by the ways of trying to explain how it is usually implemented in Perl. That's what they are doing, as anonymous subroutines with a lasting reference. And look at the way they explain things, as anonymous subroutines with lasting references to lexical variables outside their own scopes. That's just a full mouthful. Now, this lexical. Now, granted that closure is not it's not a simple concept. It's actually slightly complex. Then it says these lexicals magically refer to the variables that were around when the subroutines was defined. Yeah. Then look at the way they drag in the word magical. Pro people loves that. They love the word magic. They things like that. Okay. Then second paragraph. Closures are closures are now, if you keep comments coming, okay, keep the comments coming. Type any your thoughts, your comments. Let's get back to the Perl. I'm trying to finish this quickly. I'm trying to get to the main dish where I begin to explain what closure is to beginner programmers. Then I'm going to go into why I don't like it. So the second paragraph of this says, Perl people says, closure are most often used in programming languages where you can have the return value of a function be itself a function, as you can in Perl. Note that some languages provide anonymous functions but are not capable of providing proper closures. The Python language, the Python language, for example, you know, this is one thing Perl people love to do. They want to, while they are trying to explain to you what closure is, they also mix in, mix in propaganda. They want to tell you how great Perl, the language is. Then they want to drag in Python because Perl and Python was the arch enemies. They want to drag in Python and slight, like belittle Python a little bit. So here they are trying to say, basically what they are saying is that this actually is wrong. Well, basically it's partly wrong, partly incorrect. They are saying closure is most often used in programming languages where you can have the return value of function be itself a function. That does not actually address what the heart of the thing. But it is true that you create a closure by having a function that returns a function. That is what they are trying to say. Okay, and that is also why closure is just no good. Okay, I don't like closure. Okay, but anyway, then you look at so you see, as you can in Perl, that's how they want to drag in. That's how they want to put a bit of promotion of Perl. When you start to do this, they do this throughout their documentation. Okay, I've read the entirety of Perl documentation, basically word for word. The entirety of Perl doc. Okay, there's a book. I've read the entirety, several times, and in fact, I've read all books of Perl in the 1990s, all of them. I have written a review of all the books, Perl Books Survey 2002. Okay, from 1998 to 2002, I have read all, basically the top five Perl books there exist, and this is my page. I talk about, I give you a review of each. And besides this book, I have read the entirety of Perl doc, several times, word for word, every word of it. So and then the Perl documentation, then they drag in Python. They say, Python cannot do it. That's true in Python 2, but Python 3 improved it. Okay, and I'm going to show you. So let's go to the third paragraph. So in human terms, it's a funny way of passing arguments to a subroutine when you define it as well as when you call it. In human terms, it's a funny way of passing arguments to a subroutine when you define it as well as when you call it. What do you mean? It's a funny way of passing arguments to a subroutine. I'm a little bit unfocused, and I'm not quite sure what it means. I'm getting tired now. It's useful for anyway. Yeah. Anyway, that's their explanation of closure in the Perl. Oh, wait, hold on a second. Actually, we are back here. So anyway, yeah, so this is Perl FAQ, and we go to the Perl ref, and Perl ref says anonymous subroutine act as closures with respect to my variables, that is variables lexically visible within. Anyway, so that is Perl official explanation of closure. Okay, and I'm going to tell you what closure is. So let's read the comment a bit. Let me drink and take a break. So are you guys still here? Say something. 6 people. So Norman is asking a question, and that question is probably a bit advanced. But I want to finish my beginner's tutorial on closure. But let me just read out a comment for now. So Norman says, what do you think about closures that aren't returned from their containing scope? For example, if you create a local helper function in the parent lexical scope. In the parent lexical scope. What do you mean? Like, so are you so nested function, right? And I don't quite understand the question. So let me know exactly what you mean. In order to close, as far as I know, in order to create a closure, you have to have a function that returns a function. But again, the definition of closure is a bit depending on what we mean, because we may not be thinking of the same definition of closure. So what do you mean? So Norman, so explain. Let me know what you mean, and I'll get to it. So let me get back to, so what is closure? Okay, let me explain what is a closure. Closure is a feature of is a specific feature of programming language. Closure. Now the closure function closure is a feature of a function. Okay, it's part of a function. This feature is tied to function. So what it means in a sentence is that, okay, here's one way to put it. Here's what means the best explanation of closure in one sentence of the century of humanity, of the whole history of humanity. This is the best summary of in one sentence what closure is. Okay. Closure is a function. Is a function in a programming language. A closure is a function in a programming language that the function's local variables works. Always just works. That's all. Okay, that is the best explanation of closure of the entire history of humanity. Okay, what is closure? Closure is a function in a programming language. Closure is a function such that its local variables always just works. Okay. Period. Okay, that's what it means. Now, okay, so that may be puzzling. What do you mean it always works? Of course, local variables always works. What do you mean it always works? I mean, are there examples where local variables does not work? I mean, you mean if that's the case, that's a bug in the programming language, right? Or it's it's a bug. How is it possible? What do you mean a local variable doesn't work? What do you mean it always works? Well, let me show you an example where a local variable does not work. Let's begin the journey into closure. Okay, this is a journey into closure. You cannot refuse to not understand. You will understand. You'll see step by step the gist, the nature of closure, why it arises. What is the original problem? Why does it arise? Okay. So let's use JavaScript then. Let's yeah because let's arrow function. Let's see. Actually, I can do it. I I haven't done this before. Let's see. So are you guys always with me? Give me something feedback. Uh, you know, 3 people. Okay, I'm losing people fast. It's okay. I'm kind of discouraged. Constant arrow function. Okay, okay. Let me try to get over this quickly. So we want to define a function. So we define a function f. Okay, f is a constant function, and okay, a constant function that takes a value of x and returns a value. Let's just say return. Okay, so let's say return x. Okay, here so we have a function that returns x, and let's call it let's say 3, and let's run it. Okay, save the file as that, and let's run it, and we got the answer 3. So we have a function, we define the function. This is a lambda function, anonymous function. It's just a function expression. Okay, function takes a variable x and we just return it, and let's say return x plus 1, so we get some difference. So it returns 4. So and we assign it to a name f. So f is a function. So f3 returns 4. Okay, now we have a function. Now let's define some local variables. Okay, local variables, let's say. Okay, so we let's try to do that. So let y equals to 3. Okay, yeah, y equals to 3, and let's say x plus y. Okay, now we have a function that has a local variable y. Okay, and this function returns x plus y. Okay, let's run it. 6, that's the right answer, because we give it 3 and it returns 6, because 3 plus 3 is 6. Okay, so far so good. So we have a local variable. Now what I want to show you is a situation when local variable does not work anymore. It does not work anymore. That's a tricky situation. Okay, okay, let's do it. So in this function, I'm going to define another function inside this function. So it's kind of a nested function, inside this function. So let's do that. Let's just say let. Okay, let's inner f. Okay, it's kind of let's say f2. Yeah, let's call it f2 then. So let's call the first one f1. So we have a inner function f2, and this inner function, let's say it takes no argument. Okay, and let's say it returns 3. Okay, this is just for now, it returns 3. Now let's do that so that we get indentations. So yeah, actually okay, so anyway, so we define a function f2 inside this f1 function, and this f2 function takes no arguments, and it returns let's say not it returns 3. Okay, let's say it returns 2, and now let's run it. It returns 6. That's still good, because nothing changed. We defined the inner function, but we did nothing. We didn't call it or anything, so it's still so far so good. Now let's do something else. Now let us return. Now let the main function returns f2 let's see, hold on a second. We want to create a situation where a local function, a local variable in a function no longer works. So a local variable in a function no longer works. So let's add a local variable here. Okay, so let's see. Let's return y. Okay. Yeah, let's just return that and return f2. So what I'm doing here is, you see, the f1 is a function. It has a local variable y, and it also has a local function, a function f2 inside this function. And this function returns the local variable y. And this f1 function actually returns f2. So this f1 function actually returns a function, and returns an inner function. So what happens if we call f1? If we call f1, it's actually just returning f2. So let's try to run it. So you see, it returns the function f2. Now there's an interesting thing here. This variable y is local to f1. Okay. Let's do this. Okay, so let's let f3 equals to f1. Okay. Now remember f1 returns a function. So what we are doing is that whatever it returns, we assign it a name, f3. You see what I mean? So we can run it. So whatever it returns a function, and now we give it, we assign it to f3. So now we can call f3. Let's call f3, and let's see what it returns. It returns 3. You see, what happens here is that this f1 returns a function. What does it return? It returns this function f2 here. And what does this f2 do? f2 is actually taking a variable y that's defined in f1, and it just return it. So that's why this f3 returns 3. So it all works, but what's the deal? So there's an interesting thing going on, because when you return y, you see this y is part of f1, but f1 is already done for. Over here, when you call f1, it's already finished. But now when you call f3, that y came from f1, but however it kind of still is still there. So this is actually what I'm trying to say when a function's local variable no longer works. Actually, it was a incorrect statement. What I'm trying to say, it's not about the local function no longer works, but rather a variable used by the function. You have a situation where a variable used by the function can sometimes no longer exist, because look at this f2 is a function. It uses the variable y, but y is defined as a local function in f1. So in many programming languages, when f1 is done after it's called, the y variable is already gone. So the f2, you have a situation, this f2 has a variable that's already doesn't exist anymore. So in some languages you cannot have the situation like this. So it's an issue. This is actually why this is a complicated advanced issue about closure. So what I'm saying is that so language designers and who implement this have to come away so that when a function is gone away, but however if its variable is still used by some other function, it's still used somewhere, it should still work. Okay, so this is why, so it should still work. And this situation where a function's variable, whatever variable it uses, is guaranteed to always work. This is called closure. Okay, this is what closure is. Okay, so so that is what closure is. Okay, is that clear, or is that it's a little bit complicated. So actually, my that one single sentence explanation, closure is just a function where it's the variable it uses always works, not local variable. That's a mistake. So closure is just a function such that all the variables such that it just always works as expected. That's one way to put it. Almost specifically, the variable it uses always just works. But there's a problem here. When you have a closure, there's an issue. For example, let's see. Let's say. For example, let's do y equals to y plus 1. Okay, let's do that. We run that, so it returns 4, right? And let's run it again. You can we run it several times. You see, the result is 4, 5, 6, 7. Why? Because it actually maintains. You see, this variable y is a kind of a internal variable. Nobody can access this variable y because f1 is already gone. But however, it's still there. It's maintained. It kind of maintains. It comes with the f2 function. So closure, another way to say what closure is, and this is the most standard way to when people say what closure is that it's a function that has its own lexical environment. That's how people say it. It has its own lexical environment. It just means that all the variable uses it still come with it. It's like you have an environment. It's still, you have a bubble that comes along with a function, and it's enclosed. That why is it called closure? Because it's some kind of a enclosed thing. This whole thing, the whole variables that's used with the function f2 come with it. Whenever you return a function, whatever variables it uses always stay with the function. So when you define a function in a language that supports closure, it means whenever you have a function, it just maintains all the variable environment with the function. That is all it is. So that the reason it's called closure because it's like a enclosure. Actually, a proper term is lexical enclosure. Okay. So I you can read this article. I'm doing video, so I'm kind of verbose, but you see my visual facial expressions, and you kind of get to see my process of thinking through it. I hope that's helpful. But if you are impatient, you can read this article because I have several articles. I have one in JavaScript and in Python 3. I show you how to do closure, like this article in Python 3. I show you how closure is done in Python 3. And actually, I don't have an example in emacs lisp, and I was thinking of coding it in real time, but I probably talked for too long. I spent too much time on the rant on closure from the Perl people. So I was thinking of doing a real-time coding of closure, showing you how closure is done in emacs lisp, which is well, anyway. So I think let's skip that. But anyway, so you can read this article that explains several issues about closure. Okay. For example, there is a I'm going to get to some of the items. So a better name for closure is lexical enclosure. Okay, it's called closure because it's some kind of enclosure. Because when you define a function, it encloses everything it uses. It comes as a one package. So, but the most important and practical consequence, the most important thing people use Clojure for is actually the state, a function that maintains state. That's what people use it for. That's the gist. That's the consequence. That is the use of Clojure. It's not about the enclosure or thing. That's just technicality. That's just computer science technicality. When programmers use Clojure, what you really want, why do you want this feature? What you really want is you want a function, okay? You want a function to have a internal state. Like our example, you call it multiple times and it returns multiple different values because there's a change of state. You can change the state or you can change y to something else. That's what Clojure is used for. That's the manifestation of Clojure, the actual use of Clojure, maintaining a state. And also, because of this, Clojure is no longer, technically, Clojure is not a function anymore. It is not the mathematician's ideal concept of function because it has side effects. Because the function's return value no longer depends on the input. Because right now we have a function, we call it multiple times. Each time the input is the same, no value. But however, the return value changes. It's different each time you call it. So in a math sense, in a pure functional programming sense, Clojure is a what? It's a thing you don't want because it has side effect. It's no longer a pure function. This is the reason I don't like Clojure. And okay, so let me get clear. Let me summarize a little bit. Let's just clear out the 1 hours of talk. First of all, Clojure is a programming language feature. Some programming language has it, some doesn't. Okay, some people like it, some doesn't. It's not really necessary, because it's just a programming language feature. Now, what Clojure is actually it's a function such that it comes with a environment of all the variable it uses, so that the function still works as you would expect. People would say it's a function with its own lexical environment. That's what Clojure is. Now, why is it called Clojure? It is because it's some kind of a enclosure. It's like closed. It's a house. It's a circle. It's a bubble. It's a lexical enclosure. That is why it's called Clojure. Now, why? Now let me talk about why I don't like it. I don't think it's a good thing. Okay, in programming. Why? No. Wait. Hold on a second. Now let me talk about why is it useful? Why people like it? The reason people like it, the reason its use is because it creates a situation where you can have a function that maintains state. And as a consequence, you can also have a function. In fact, this is the heart of object-oriented programming. Okay, when you define a class, what does class mean? Class is a closure. That is the technical essence of a class of object-oriented programming. The class concept in Java, in Python, in Ruby. Okay, a class, technically speaking, is from the perspective of computer language design, a class of OOP is a closure. Okay, that's what it is. Because of the feature, programming language feature of closure, that is how you can define class. Otherwise, class is impossible. Because of the closure feature, the lexical enclosure, therefore you can define a class in Java, in Python. Okay. So, but why do people want to use Clojure? What is it used for? Now, basically the only reason, the reason is that it allows function to have a state. such as when used in OOP. For example, when you have a class, you have what's called fields, members of the class. You have methods. Those are all local to the function, the class. So class in our case is kind of the outer function, and the methods are the inner function, such as the f2 here, and the fields or members, member variables, static variables of a class is like the variable y here. So that's what OOP came from. It kind of came from the functional programming, kind of. Okay, this is not real history. Okay, I'm just saying technically speaking. Okay, anyway. So what's a closure used for? It's used for the state, for function to have a state. Now, if you don't have a closure, can you still do that? Yes. All you have to do is just use global variables. That's a simple way. So you just have a function that uses global variables. Each function can use global variables. Then each function can maintain a state. You can do whatever you want. You can do whatever you want to do with closure. So if you have a language that do not have closure, that's good, because I don't like closure, because everything possible, doesn't matter what a closure can do, you can do it with your function just by using global variables. Now you might complain, oh yeah, but global variables is bad because you have different functions, they may stamp on each other. That is true. Well, how do you solve that? You can solve it by creating a scheme such that the global variable names used by each function is like a random, systematically random, and connected to the function, such as cryptography, public encryption. You have pair of keys. That's one way to solve it. And anyway, that's kind of my sting towards those people who like closures. Those are idiots. Okay, programmer, the hacker types. They don't understand what it is. But anyways, what I'm saying about this global variable use is it's actually true. That is the practical equivalent of closure. You don't need closure. It is from a functional point of view. Functional meaning that what your program actually do. Everything that's with closure you can do just by using global variables. Such a simple idea. There's nothing, you don't need closure at all. Now the next part and last part, why I don't like closure. Okay, first of all, the reason I don't like closure is, one, it's not mathematical function anymore. You are getting into OOP, or you are getting into a function. A pure function by definition is such that a function's output always depends on the input. It's a map. Okay, same input always have the same output. But that's not the case when you have a closure. When you have a closure, you start to have, it's almost like anything flies. Anything can fly. You can have a function that returns a function that returns a function that has, so many levels of inner variables. You could, we can actually start to code it. You can have not, what OOP class, you call class, class variables. You can actually have several levels of class variables. You have like several levels of closures. So when we say closure, we can actually talk about closure level n closures. It quickly becomes bizarre and complicated and extremely useless. So that's what So first of all, I don't like closure because it's not a function anymore. And also because it can get extremely complex, when you start to have closure. Because the reason mathematicians or pure functional programming, the reason we like the concept of pure functional programming is because functions has no side effect. Closure, by the very nature, by the very definition, it's a function with side effect. It's no good. Okay. So that's why I don't like closure. Secondly, the second reason is that whenever you want to create a closure, you cannot just say define closure, like define closure and define your closure. That's not how it's done. you always of all the language I know of, Python, Java. Well, I don't know about Java, but Python I know. Emacs, Lisp. Actually, I don't know. Anyway, Java, at least JavaScript and then Python. Okay, at least JavaScript, script and Python. I don't know at the moment about Emacs, Lisp. I have to think about it. But anyway, at least Python and JavaScript. When you want to create a closure, you always have to do the only way, the prototypical way you create a closure is by defining a function, defining an inner function, and return the inner function. That is how you create a closure. After you do that, then you have to call the function and assign it to another function, just like the example we have here. So in a sense, it's rather extremely complicated. In fact, when you look at this form, this is how you define class and how you create object. It's almost identical. You see, this F1 here is a class, you know, and this F3 here is an instantiation of a object from the class F1. This is the origin. So anyway, when you want to create a closure, this is almost like the only way you do it. This, and in fact, by the definition of closure, you can see that this is just, there's no way out, because closure by definition is a function that comes with its lexical environment, and only via, I think, I'm not sure theoretically, but I think only via this way, having inner functions, that's how you can create closure. Okay, so you can see it's fairly, very extremely complicated thing. I don't like it. Okay, so I think that's kind of that concludes what I have to say about closure. 90 minutes talk. Okay, so if you guys have a comment, type it, within 10 minutes, and we can go over. And I think maybe that would be it today. A lot rant today about closure, because it is one of the big rant in my 20 years of coding. In the first in the first 10 years, I actually don't quite understand what it is, and then, but anyway. So let's see what. So type your comments, and so I'm gonna go through the comments. Hey George. So Norman says, so okay, hold on a second. Shakha gives this web page. What this web page is about? VLFI, view large files. Okay, that's about how to view large file, related to view large file, open large files in Emacs. Okay, you guys can read that. Thank you for the link. And Norman says, what do you think about closures that aren't returned? Okay, yeah, and Norman says, not only the local variables always work, but each closure's variables are independent of other made it the same way. Yes, that is true. Well, anyway, yeah, so Norman is mentioning about. Anyway, so next question is Lisp worth learning? Well, that depends. That depends on a lot of factors. But if you just bluntly ask me that question, my answer is no. That's, because a lot of my followers is actually Lisp fan. They follow me because of my, my Lisp expertise, and also, we, supposedly we like to promote Lisp, but actually, so anyway, that depends on a lot of things. Whenever people ask, which language is worth learning, and there's an answer, usually it's just nonsense. So I can tell you, I mean, if you ask me, is Lisp worth learning, I say no. There's no much meaning to that. Forget about that. But so it depends on a lot of things, like what's your goal, and what's your personal situation. For example, what's your goal? Do you want a language that actually gets you bread? If so, no, don't learn Lisp. Okay, Now, if you are interested in history of artificial intelligence, suppose that is a specific question you have strong interest, then absolutely you have to learn Lisp, because that is the Lisp is the kind of the entire 30 years of Lisp artificial intelligence history. Okay. Um, then if your question is, you are interested in programming language design, or concepts in programming languages, what is Lisp worth learning? Then the answer is yes, I would say. So among others, Haskell is also a good choice. Haskell, F sharp, or Camel, those are all good choices. Or Idris, or Cog, or, there's so many. There's Forth, and there's Mercury logical language. Okay, Prolog, for example, Mercury Prolog, and so there's tons of languages. So if you are interested in maybe some kind of programming language design, yeah, Lisp is one of them. Let's say top two. Learn Lisp is a good thing. You learn the parentheses, nested parentheses is kind of unusual, but you also learn the concept of kind of a systematic syntax and how they can be transformed. You start to learn macros, Lisp macros, which is extremely idiotic. Okay, but however, it's a jump point to the much more important concept of pattern matching. Not Haskell pattern matching, but symbolic pattern matching. Okay, in Mathematica, Lisp macro is a step. It's a jump point to get you into the beautiful world of symbolic pattern matching, which in turn is a step towards understanding um, uh, computer algebra systems, in understanding implementing computer algebra systems or how they work, such as Mathematica, Maple, and a bunch of others. Symbolic, meaning that you can solve symbolic equations, symbolic derivatives, or integration in symbolic forms, symbolic computation. That's Mathematica and Lisp. Okay, so let me summarize. So Lisp, yeah, Lisp. If you are interested, one of the things you may learn from Lisp is Lisp macros, which is idiotic concept, most frequently cited by Lispers and common Lispers. Those people are idiots. Okay, Xardi says. But however, Lisp macros is a stepping stone to understand symbolic pattern matching, which is not in Haskell, not in OCaml, not in the other ones. They are in Mathematica. Okay, symbolic pattern matching. Now, symbolic pattern matching is a stepping stone to understand how computer algebra system works. That is symbolic solutions to integration derivatives or manipulating of formulas and so on. Okay, so that is kind of my coverage of which is Lisp worthwhile. Okay, so in general, if most people asking questions, then you have so many criterions. Is it good for looking for a job? Is it good for bread? Is it good for interesting? So many. Is it still relevant? Lisp today is really not relevant. Not even relevant in artificial intelligence today. Okay, this is totally irrelevant. Have basically no place. It's practically correct. It's correct to say Lisp today practically has no place, no position, no footprint in today's artificial intelligence computation community. Okay, they are not done in Lisp. Lisp has no place. So that's another point for you to judge whether you want to go into Lisp. This. So in my opinion, if the blank question is well, anyway. So yeah, that's my take. So Erland. So okay. So let me go over the comments, and I gotta go to the bathroom too, so we'll be done. So, so hope George, do you like my answers? Is it good? Is it does it answer or does it? Yeah, let me know because I always, of course, people like to know if I did good. Let me know. So Norman says for fun or personal interest, maybe. For work or practical use, no. Yeah, that's a good. I would say I agree with that. Daniel says Lisp was used in AI until end of 1980s. Yes, up to 19 yeah up to 19 early 1990s. Yeah, it's kind of AI winter, as they say. Daniel says the progress, development, and evolution of Lisp was tightly related to the other progress, development, and evolution of AI. That is correct. Norman says, I didn't appreciate how good pattern matching is until I learned Erlang. Okay, I have a question. Is Erlang's pattern matching, is it symbolic? That is my question, because in my learnings I learned that Haskell, pattern matching, or Camel, their pattern matching is entirely different because they are not symbolic. So they are not when you and because of that, it's entirely different thing from languages with symbolic pattern matching. Uh, because when you are matching by values, there is a huge difference. The nature is their power, their computation nature is entirely different. So is Erlang's pattern matching, are they symbolic? Because when you have symbolic pattern matching, what it means is that what you have is basically transformation of syntax or transformation of source code. Lisp macro is like very puny. It's like impractical. It's just a little bit of that transformation of source code. Like if you are into Lisp, if you read into common Lisp phonetics, they like to say, oh, Lisp, Lisp is a language that can a language that source code returns source code, that programs that modify itself. There's a Lisp, common Lisp. They are idiots. The Lisp macro, and the reason they say that is because Lisp macros, but actually Lisp macros is actually in an ineffectual. It's like 5% of 5% of real symbolic pattern matching feature, a full symbolic pattern matching feature in Mathematica and other languages. There's others, okay, obscure, but anyway, Mathematica is the primary one. So why is Lisp people like idiotic like that? Common Lisp, because the reason I say is that because I've been fighting with common Lispers for over 10 years. They call me a troll. Okay, I've seen professors, even professors, they make the extreme idiotic and incorrect expressions about common Lisp. The reason they are like that is because the common Lispers I'm in touch with is mostly since 1990s. By 1990s, Lisp has already gone downhill. It's not the hate of Lisp. Okay, so the people after 1990s, the enthusiasts, the phonetics, they Lisp has become this mythical language, and Lisp has already died. It becomes common Lisp. Okay, it has already fell out from the hate of language research. So instead of you have this common Lisp, which is extremely ugly in late 1980s, extremely ugly language that tries to merge all the commercial versions of Lisp as a kind of, they try to go forward as a standard. Because back then in 1980s, there are so many Lisp dialects, and they are at war. Serious language war, like each other fight. Just like today, I call you an asshole. You are an asshole. Because you are Lisp Y. I'm the best. I'm Lisp X. Okay, and somebody Lisp B says, no, you two are idiots. Lisp B is the best. People are doing that back then. Because I read history, I've seen it. I didn't, until I read it. The moment I read it, I'm like, I was going like, oh my God, I didn't realize. You have to dig history, because once you dig into so many things you don't realize. Then I only read a little bit, but I did realize it was like that. But anyway, by 1990s, the lispers, they most people, just like everyone, lispers, they don't dig history into that deep. What they are actually are rather just the phonetics. Just like today on Hacker News, you have average programmers. They read someone wrote something and they get excited, and they from that day on they tell everyone, oh, we all should do patterns X, from now on something is good, something is bad. Those are idiots. Okay, agile and all that, and Unix philosophy. That's one of them. So the lispers, common lispers, from what I see, by 1990s, they are not original. I mean, just like any other programmers, they are prone to fall into fads and fashions and beliefs, and they want to believe that Lisp is these great, wonderful things, and in turn, they don't get into something in detail. I mean, also, even in 1990s, compared to Java, okay, Java, Lisp was mainstream, but by 1990s, by 1998, it was not mainstream. It's kind of the niche, okay. The mainstreams are Java, C, C++, okay. So in comparison, Lisp is still better. I mean, in my opinion, better than Java. So to a lot of Lispers back then, when they talk about Lisp things, they are thinking of, their mindset is in comparison to Java. Therefore, Lisp is superior. That I agree. Okay, that's my opinion, because I like functional programming. I despise, the imperative. So when these Lisp fanatics, they are saying Lisp is so great or superior, they kind of also, they are in comparison to Java, C, you know they are not really, thinking about symbolic pattern matching. They they never, they don't know Mathematica. They didn't dig into specifics of things. They are just following trends, just like average other programmers. So that is why, I think a lot of these lispers, when you read a lot, I mean, even today you have a lot of phonetics, they say good things about Lisp, and to me, their ideas basically, they are just incorrect. They are just, factually, technically incorrect. They are spreading incorrect information. Uh, but those are informations, people want to believe, just like religion. If you are a fan of this, why are you a fan of this? Because it's kind of niche, right? Because it's kind of all the parentheses, because it's unusual, and you are an unusual guy, so you want to, we are in this group of, the mainstream, so we like it. I like it too. First of all, compared to Java, Perl, absolutely I like this. But it so happens, I also tends to, I don't like, I don't, I tends to be non-conformal, even in the non-conformist community. But anyway, that's just me. Okay. So although Mathematica's pattern matching, so Norman says although Mathematica's, hold on. So Daniel says list problems, lots of dialects, lack of well-known libraries. That is true even today. Weird syntax that does not contribute to abstract people in dynamic typing act. That is also true. I mean, for example, one problem along this line is that, in Lisp you cannot have a function that return a function. You can, but you have to go. You have to go around things. It's not practical. So on the other hand, in JavaScript and Python, you can trivially, you do it all the time, have a function that returns a function. But in Lisp, it's a problem, and so therefore it's not an idiom. So so that's one of the problem Danielle mentioned about this issue. Uh, I think I think that's what you are saying. Part, I suppose. So Norman says, although Mathematica's pattern matching is probably more powerful, I think. Danielle says, notice that programming language might not be very important. Okay, good answer. Great, thank you, George. Can you explain symbolic pattern matching? That's that's another topic. Okay, I hope that I did cover that. It's just like list macros, but actually designed for it. Yeah, I hope to show you. Actually, if you like to know that, right now I have an article. Sorry, um, problems. I have actually pattern matching several articles. I have one specific article that tries to teach. Yeah. Anyway, I hope so. Maybe next time I'll explain that because I have like over 10 articles about that, about pattern matching. So you can read, just search for Xali list pattern matching. So Norman says Erlang's pattern matching does not involve source code transformation. It matches the shape of data. Okay, using normal type syntax. So I think that's value based pattern matching. Yes. So I think that's I I don't know for sure, but I think that's the same class as Haskell's or Camel's pattern matching. So they do match structures, and also they match values and type as well. The type of values and structures. So George says Paul Graham predicted wrong when he said that Lisp will be the next big language. Yeah, I mean a lot of these big people, I mean George Paul Graham, when you list a lot of celebrities, they always have big things to say. For example, Bill Gates, he was the richest people in the world. He always have opinions, and whenever he says something, all the people is going, oh yeah, this or that. They follow him. And similarly, a lot of these celebrities, they always have big things to say, and all the programmers is like following them, and kind of once they say something and all the programmers is like believing, and you began to have a fad. Paul Graham is one of the guy who kind of began a fad about common Lisp, or about Lisp in 2002 also, because of his article about Lisp, because he wrote a Lisp sold to Yahoo for millions of dollars. But anyway, what I want to say about that is whenever some people, famous people, they become famous for a reason, mostly because they are successful in particular thing they are doing. For example, Bill Gates, what is he good for? He's good for running a company. He is expert in that, no doubt. He's a expert in entrepreneur, and so therefore, if he has an opinion that's related to entrepreneurship about startup, listen, okay. If he has an opinion about anything else, it's probably good to ignore. Because he don't know shit about it, including programming. He is not known for as a greatest programmer. Rather, his success came from his ability to start a company and sell the company. Same thing as an example, Paul Graham. What is he good for? He's good for writing the Common Lisp program and sold it to Yahoo for millions of dollars. He's good for that. So whenever he has opinions about Common Lisp or Lisp in general, we listen about programming. Okay, technical opinions, not about whether Lisp is a good language or not. That's kind of a different field. That because to speak as an expert in about which programming is better than others, you actually have to be well known as a programming language designer and also expert in all these languages. Also, you have maybe wrote several great, well-known programs, critical programs in different languages. Then we can accept you as someone who is an expert when you have a comment about which language to learn. But program Graham is not really not that. He might know, he of course he know other languages, but he is mostly well known for expert common lisp programmers who has written this program web store, and he's also known for starting a company. He's known for entrepreneurship. So whenever he has an opinion about these specific topics, I think it might be good opinions, but otherwise, screw it. Okay, same thing. A lot Nobel Prize winners, politicians, whoever, they have all sort of ideas. Whatever they say, or celebrities like stars, today's singers or movie stars, they have all opinions about politics on how a country should run. Do you actually believe them? Do you think you should believe them? Judge for yourself. Okay, that's it for today. So thank you guys for watching. uh Now, if you like my show, I have Patreon and PayPal on any of my blogs. You can go to, you can see there's a link to my Patreon and also my PayPal pages on my PayPal, or Amazon gift. So drop a few bucks, that would be appreciated. Uh, and otherwise, hope to see you next time. Link to my blogs, link to my talk show, spread it. That would be that would be great. Thank you. See you guys next time. That was 2 hours talk. Bye.